Hi everybody, this is Mr. Acevedo speaking, and I wish you are having a great time. Today we're going to continue with the explanation about functions, a review of what we have seen so far. Now, let's go with the structure of a Cartesian plane. A Cartesian plane is made up of two axes. The axis x, that is the horizontal one, and the axis y, that is the vertical one. When we have coordinates, the first number is located in x-axis here. For instance, 2 is located in x, and the second number is located in the y-axis, 3. So 3 is located in the axis y, both positive, so we find them here in this quadrant. In this example, minus 3 is located in x-axis but negative, and 1 is located in y-axis but positive, Now, the function notation. What is y? Y is the output, is the result, is the answer. And x is the input, I mean the value that we assign in order to get the answer for y. And f is the name of the function, but you can also write g, h, any other letter, doesn't really matter. Now in this function, we can conclude that this is a linear function. Why linear function? Because we get a line. And analyzing the equation, we can also conclude that the slope is 2 and the intersection in the y-axis is minus 2. Let's see, minus 2, of course here, it intersects here, y-axis is minus 2. And the slope is 2 positive. Let us see. We go upwards 1, 2, and 1 to the right. So this is the equation to this function. And here to verify, we assign some values to x, and according to that we find the value of y. Now the graph of a linear equation. It has the same structure I told you before. mx plus b. If we observe this graph we have to the left, we can obtain the function. Let's see how. Okay, let's go to the intersection, to the y-intersection. It intercepts in 2. And now this is the y-intersection plus 2. And now the slope is positive because the line goes upwards. So we count 1 upward and 2 units to the right. So the slope is 1 over 2 x plus 2 because of the y-intersection. This is the function of this graph. Let us see the other one. For the other one, we locate 2 points, and we have the 2 points here, this one and this one. We can infer that this is negative because the line goes downwards. So let us count. 1, 2, 3, 4, 5, 6 units downward, and 2, 4, 6 units to the right. 6 over 6, but if we divide 6 over 6 we obtain 1, but negative, so the slope is minus 1x, but it's not necessary to write minus 1x. We just write minus x, and the y-interception is 6 plus 6. This is the function. This is the equation of this graph. Well, in a function we have to bear in mind the domain and the range. In these coordinates, the first value corresponds to y, and the second one corresponds to x. The first one corresponds to x, and the second one corresponds to y. The same here, the first one corresponds to x, and the second one corresponds to y, and so on. The value we have in x cannot be repeated. Here we have 1, 2, 3, 4, and 5. And in y we have 3, 5, 4, 7, 2, or any of them repeat. If a number from the x-axis, from the domain, is repeated, it's not a function. Value from y can be repeated and it remains being a function. For instance, here we have 1, we have 2, and 2 is repeated twice. That's why this is not a function, because the value in the domain is repeated. We can observe that also here in this example. We have the values of x, and here we have the values in y, the domain and the range. This is the domain and this is the range. We have two values in the range, but it does not really matter. The important thing is that we have one single value in the domain. A custom function is a function that get a parallel line to the x-axis, y, let us see. In this case, we have this parallel line to the axis y, because there is no value in x, or the value is 0, but any number multiplied by 0 equals 0. That's why we are always going to have plus 5, independently of the value we give to x. Here we've got another example of a function like this. The function is 0x minus 2. So we're going to get a parallel line with y intersection in minus 2 to the x is x. Going with the domain of and range of a function. Another graph. Identity function. Identity function is when an identity function is when the value of x is the same value than the value of y. Let us see the chart. When x minus 2, y minus 2. When x minus 1, y minus 1. When x 0, y 0. So in this case, y equals x, and the base pair are here, the coordinates. Two more linear functions. Here we have the equation, another equation with a y intersection in minus 2. Of course, we find here that it's in minus 2, and with y intersection here in plus 3, like this. Now, take your time, analyze this graph, and try to find the function. Ready? Okay, now I'm going to do it. First thing I'm going to do is to plot 2 points. I have one here, and I have the other point here. Can be any point, it doesn't really matter. It's positive, so I'm going to count upwards. 1, 2, 3, 4, 5, 6, 7, 8, upwards. 1, 2, 3, 4, 5, 6, 7. So this point doesn't work. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 upwards. Now let us see to the right. 1, 2, 3. But 9 divided by 3 is 3, you know? So the value is 3x, and the y intersection is in minus 4. This is the function, 3x minus 4. Another one. Try to do it. Take a minute to do it. Okay, here we go. 2 points. This one. I usually take the y intersection as one of the points because with that point I can infer the second part of the function, that is the intersection. And the other point can be this one. It's negative, so I'm going to count downwards. So downwards we have 1, 2, 3, 4, 5, 6. And to the right we have 1, 2, 3. 6 divided by 3, 2. That's perfect. 2. So the slope is 2 and the y intersection is 5. This is the equation of this graph. The domain and the range of a linear function. The domain, I mean the values found in the x-axis, go from -infinite until infinite. And the same thing happens with the range. I mean the values found in the y-axis, they go from -infinite until +infinite. In a quadratic function, it depends on the vertex of the parabola. But always we get a parabola. In this case, we have a parabola. One thing that we can conclude from it is that it intercepts in -2 in the y-axis. So the function must be something raised to the second power -2. And this is a cubic function. This is a topic for another class, but one characteristic of a cubic function is that it has 3 interceptions in the y-axis. Well, I hope this video has been helpful for you. Then we go with the second part, this rational and root functions.